In this video, we are going to discuss the nomenclature of the derivatives of benzene. At first, we will discuss the halogen derivatives of benzene, such as here chlorobenzene, by substituting a hydrogen atom with a chlorine atom here. And also we have bromobenzene, iodobenzene, and fluorobenzene. When we introduce a nitro group to the benzene ring, nitro group meaning NO2 group, or like nitrogen dioxide here. It's called the nitro group. So this nitro group, when introduced to the benzene ring, it's called nitrobenzene. We also, if we introduce methyl group to the benzene ring, then the compound is called methylbenzene. And if we introduce ethyl group to the benzene, the compound should be called ethylbenzene. There are still more examples on the monosubstituted benzene, such as if we like substituted this cyano group with a hydrogen atom in the benzene, then we get benzonitrile. If we introduce a hydroxyl group to the benzene ring, now we get a group of compounds called phenols. So this compound is called phenol. Another name for methylbenzene can be called toluene. And if we get the acid of the benzene, which is the introduction of a carboxyl group or carboxylic group, carboxylic acid group to the benzene ring, then we get benzoic acid. Now the aldehyde of the benzene is called benzaldehyde by introducing this formyl group here. And the ketone of benzene here, the methyl ketone of benzene, is called benzophenone, as we can see here. Also, we have styrene by substituting one hydrogen of the ethene molecule with a benzene ring. We get styrene, and also this ether anisole, the ether of benzene anisole, and the when introducing an amine group to the benzene ring, we get the aniline. And finally, when we sulfonate the benzene ring by doing sulfonation reaction, we get the benzene sulfonic acid. Now we move on to the disubstituted benzene. If we substitute two positions, two hydrogens of the benzene with two substituents, for example here like something like chlorine atoms, we get orthodichlorobenzene. As you know already, if I number it like 1, 2, 3, 4, 5, and 6. So the second position, 2 and 6, the second and the sixth positions are ortho to this group here, and 3 and 5 are meta positions, and 4 is the para position. So this compound should be called orthodichlorobenzene because the two chlorine atoms are ortho to each other, or simply 1,2-dichlorobenzene. What about this compound? We have a methyl group here and we have a bromine atom. You can say here the bromine atom is alphabetically first than the methyl group, but the parent compound here is not benzene, it's toluene, okay? So you have to take into account that you are considering this compound. This is the parent compound, not the benzene itself, okay? So when you number, you have to number from the methyl group, the carbon which carries the methyl group. So you can number it like this way, 1, 2, 3, like from the right, or you can start numbering from the left, like 1, 2, 3, 4. And here the bromine atom can be positioned as 3, or can be numbered as 3, or be numbered as 4. The lowest number possible for bromine is 3, right? So the final compound should be 3-bromotoluene. Here is another example. You have nitro group and you have a bromine atom on the benzene ring. So uh, you can start numbering like this way, 1 and 2, or the vice versa. You can say bromine atom is 1 and nitro group is 2. Which way will you go? You can only decide if you know your parent compound. Your parent compound here is benzene. So if this is your parent and you have two substituents, bromine and nitro group, right? The bromine atom comes first alphabetically, okay? Then the nitro group. So this compound can be called 1-bromo 2-nitrobenzene. You have to start from here. 1, then 2. So the correct numbering should be like this, 1 and 2. So this compound is called 1-bromo 2-nitrobenzene, or you can say orthopromo nitrobenzene, right? Because bromo comes first, then the nitro group. Okay, then we move to the next compound. We can number from here 1, 2, 3, 4, or the vice versa. 1, 2, sorry, 1, 2, 3, 4. So if you go this way or that way, it doesn't matter. It will give you the same result in the end. But the main thing here, the main point here is that the you have to decide on your parent compound. The parent compound here is the benzene ring containing the OH, and NO2 here, the nitro group, is just a substituent, right? So this compound is called 4-nitrotoluene. Sorry, I just wrote it wrong. It should be paranitrophenol. That should be phenol. 4-nitrophenol. Okay, not toluene. Toluene is the benzene ring should carry CH3, a methyl group, so you get toluene. So another compound here. Again, phenol. You can see this is a phenol. Don't forget your parent compound should contain, if it contains OH group or a hydroxyl group connected to the benzene ring, then you have a phenol, right? So you can move either way. This way, 1, 2, 3, 4, 5, or you can move this way, 1, 2, 3, right? So which way will you prefer? 3-chloro, or you get 5-chloro? Obviously, you'll go with 3-chloro, right? So this compound here is called metachlorophenol, or you can say 3-chlorophenol, right? Okay, then we move on to the last example here. So you have two ways, right? You can start numbering from the carbon atom carrying the chlorine atom, or you can start from the carbon atom bearing or carrying this bromine atom, right? So which one will you prefer? Obviously, it's better. You have your parent here is benzene, and the chlorine atoms are just substituents. Then you start with which comes alphabetically first. Then you start with bromine, then this should be 1, 2, 3, 4. Then you have para-bromo, para-bromo chlorobenzene, or 1-bromo 4-chlorobenzene. And that's it. I hope you enjoyed the video. Thank you for watching, and see you in the next video.